And the best person I can bring on my podcast to talk about the AI on the edge is Dan, brain behind the Edge Impulse, author of the um, Tiny ML and AI on the Edge.
That just blew my mind. It was like, okay, we just wrote this couple inch thick book and you've just made it obsolete overnight. So I thought about it a little bit and realized I need to go and work on Edge Impulse. Just announced a couple of weeks ago that we're being acquired by Qualcomm. So we're going to now have a big sponsor who's helping us grow this community even bigger, spread to even more developers. Yeah, it's a really good question. And when we started out, things were very different. We were looking at mid-range MCUs, 32-bit microcontrollers like Cortex M3, Cortex M4. I don't know, in a few years, am I going to have like headphones which generate music for me while I'm walking around based on the scenery around me?
Hello, everyone. Welcome and welcome back to my podcast. The podcast is on intelligent connected solutions. And within the previous season, we were talking about the connectivity, interoperability, and cybersecurity, and many, many other topics. Today, I'm officially starting a new season specifically on the AI side. And once we are talking about the intelligent connected solution, the best way to start a conversation is the device itself, because we are talking about the connected device. And as this season is specific to AI, I cannot find a better topic than the AI on the edge. And the best person I can bring on my podcast to talk about the AI on the edge is Dan, from the Edge Impulse, brain behind the Edge Impulse, author of the Tiny ML and AI on the Edge. Thank you so much, Dan. How are you?
Really great. Thank you, Amir, and really appreciate you having me on the podcast today.
Thank you so much for joining us. So could you please give me, I know our audience, they already know Edge Impulse and most probably you, but for those that they don't know you, could you please give me a quick introduction about yourself and then we can jump into the topic?
Yeah, so I can introduce myself. My name's Dan. I'm the director of machine learning at Edge Impulse. So I run the research team at Edge Impulse, and we do work across machine learning and AI and DSP, basically trying to figure out ways to train algorithms that can be deployed to embedded devices. And Edge Impulse is a set of tools that developers can use to target embedded hardware with algorithms that broadly we call this AI at the edge, but it's really just using machine learning, signal processing, and deep learning to process sensor data and turn sensor data into useful signals that you can use in your embedded applications.
Great. And our audience may probably you're going to ask yourself why we are talking about the AI on the edge right now. Why not before? And I can tell you because I have been within this industry for the last 15, 20 years. And once we start the IoT journey, the term actually we are not really using it anymore because it's not just about the connectivity. At the time, the trend was connecting the device and just we'll figure it out later. Let's collect everything. And the link that we had was not really efficient, optimized of what we are doing today. We are talking about the satellite IoT these days. We are talking about the cellular IoT. So it's not just necessarily a Wi-Fi anymore or a wired network anymore. We are talking about the narrowband communication. So that's one part. The other part is we need to bring insight to our customers and to our users. It's not just, again, about just connecting devices and we have some sort of data points. It's what we can learn from these data points and what kind of action we can take after that. I believe with the introduction of the new MCUs, more powerful MCUs, and with the more complex logics and models, we can start thinking about some applications that we were not even thinking before. Now that's the time that we can bring everything together and AI on the edge. So that's the reason we are talking about. So Dan, could you please give me a little background about where you started and how you got to basically AI on the edge side.
Yeah, absolutely. And it's sort of a long, circuitous route. So I think I started out, I did my degree in computer networks and security, which was like a whole bunch of different random topics all brought together. But a big part of that was biometrics and also auto ID technologies. And so that covered a lot of things that I've ended up working on now, but after a long journey in between. So things like barcoding, RFID, and then also algorithms for looking at like facial recognition or fingerprinting and things like that. So basic computer vision, which at the time, this was going back like 20 years. This is all classical algorithms, hand coded feature extraction for this type of stuff. Um, but starting to think about like these technologies that are used to digitize things in the real world so that computers can understand and process them. And then I've gone on this long route. I've worked at a bunch of different startups. I've worked at Google. I've worked at some other bigger companies, but I've always had this fascination by the AI side, and I've worked on things like chatbots and NLP and that type of thing. But I've also worked kind of touching the embedded side too. I had my own startup doing agricultural technology for a while. We were using IoT sensors for monitoring indoor agriculture, and you start to build this picture of like how could these two things that I'm really interested in connect together. And I got a really good opportunity at Google. I've been working on this tool called Dialogflow, which is like a developer tool for building chatbots and that kind of conversational AI. And I was thinking, I really enjoy this, especially the developer side of it, but I'd love to do something a little bit like closer, to the metal, like low level. What do these algorithms look like deeper down? And so I went to work on the TensorFlow team, and just got there at the right time where they were looking for someone to help with TensorFlow Lite for microcontrollers, which was this first effort to build a kind of general purpose inference framework for running TensorFlow models on, bare metal embedded devices like MCUs. And I just couldn't be more excited about that. I got to combine these two things I've been fascinated by, the kind of deep learning side and also the embedded engineering, and ended up writing a book there with Pete Warden, who was the founder of that team, called TinyML, and that was kind of our introduction to how can you get started in this field. And it's really hard, right? Because there's like all this background you need in machine learning and AI, which I never trained in. I just kind of had to learn on the side as I went through my career. And then there's all of the embedded stuff and the like C++ software engineering. So it's a lot to know, and there's not that many people who have that like proficiency in both, myself included, right? I had to like get better at both sides of that to be able to work with it. So wrote this big book, and then just after we published the book, Zach Shelby, who I knew from his work at ARM, and we'd collaborated between ARM and Google before, he came by and showed me this demo of this new product that he'd just quit ARM to work on. And it was this amazing, like, user-friendly system for training deep learning models and deploying them to embedded devices. And that was Edge Impulse. I just saw this demo a couple of months in that he and Jan had been working on. And that just blew my mind. It was like, okay, we just wrote this couple inch thick book and you've just made it obsolete overnight. So I thought about it a little bit and realized I need to go and work on Edge Impulse. So I ended up making the leap from my dream job at Google and starting out as the first employee at Edge Impulse. And that was about 5 years ago. So we've had this crazy journey since. We've got like a couple of 100,000 people on our platform building really cool applications across like industry, wearables, health and fitness, all sorts of different applications, plus a really big community of people who just like hacking on this stuff. And then we just announced a couple of weeks ago that we're being acquired by Qualcomm. So we're going to now have a big sponsor who's helping us grow this community even bigger, spread to even more developers. And the crazy thing in that time, we've gone from targeting microcontrollers with really simple models processing time series data through computer vision and audio. And now we're even looking at large language models on the edge. So it's been a crazy journey.
Yeah, that's interesting. Thank you so much for sharing. Definitely, we're going to touch base on the acquisition as well at the end. Um, about the Edge Impulse, I really like the model, and it kind of reminds me of the Lab View by NI, basically the model, and most probably that was the same concept you were thinking once we start this journey. When I was doing my PhD thesis, actually, I was using a Lab View for the hardware in loop testing, and I was almost not paying anything. That was an almost free tool for me to use it. Really great tool. And then all of us, once we get basically to the actual work within the industry, later on we're going to promote the tool and the platform. I believe that was the same concept for Edge Impulse, that's free for developers. And now once they learn on how to use it, so once they go to the other companies, they can promote it. So I really like it. And how was the experience so far? Let's talk about before the acquisition with the community and the developers and the feedback we're getting.
I mean, it was crazy, honestly. Like, we came from our first release. We just, when you first allow people to sign up for accounts, and we're looking at the metrics, and it was almost immediate. We had this huge number of signups and tons of people checking out the product and trying it out and giving feedback. And we have our forum, which was really active. And it was just this kind of hockey stick graph from the beginning, really. There's a lot of hunger for this type of thing because it kind of came from both sides. There were people who were from the embedded side who had been looking forward to playing with machine learning in an embedded context, but it's kind of a pain to do without some additional tooling. There's so many conflicting tool chains, and it's quite difficult to deploy to device. And there's all of these new skills you have to learn in new programming environments. So it's something you can learn to do, right? But it's nice to have this like booster rocket strapped to your back, and so that's what we provided with Edge Impulse. Also, some really amazing signal processing algorithms too to do feature engineering for embedded. And so that was one group. And then the other group are the people who had come from more of an ML background, and they're training these models and thinking like, hey, wouldn't it be cool if we could do something in the physical world with these capabilities? And so we kind of bridge that gap as well and allow ML people to deploy what they're working on to the edge without dealing with all of these hundreds of different vendor tool chains and things like that. So it was immediately very exciting for people. And then we started to get partners on board from the silicon side. So, big silicon companies that developed these various different accelerators and processors that were relevant for this stuff. And like I mentioned, there's this whole big problem with compatibility or with different tool chains plugging together. One really nice thing about our platform is it's this kind of neutral center point where you do your training or you bring a model and then you can plug it in and then just deploy it anywhere. And we handle all that fiddly stuff with the compatibility and making sure the model's optimized for the right devices. So we were able to be really useful for the community there, and for the industry in providing a bridge. And so we've just had a lot of success with that. And then as we've grown, we've got connected with more and more enterprise customers who are doing stuff at big scale with this, shipping products to millions of people, installing things in massive industrial facilities. So it's really been this process of just one thing and the next, just getting more and more exciting. And we're about to enter this whole extra booster stage that's going to go even further.
Fantastic. So once we are talking about the AI and the edge and the device, the main things we should start talking about is the input to this model, basically. And we are going to have multiple sensors like a camera, microphone, accelerometer, any other sensors. Let's talk about actually the trend that you have seen so far on the type of the sensor users are using, and maybe you're feeding the model beyond sensors. Maybe you're feeding it with other data points that definitely I'm interested to learn. How, what was your experience so far? What's the trend you have seen between all these companies that you're working? What type of sensors they're using and how they model it?
Yeah, it's a really good question. And when we started out, things were very different. We were looking at mid-range MCUs, 32-bit microcontrollers like Cortex M3, Cortex M4 kind of things. You've got a little bit of, um, SymsysNN vector extension stuff maybe on the chip to help accelerate some of the vector math that's involved with computing deep learning models. But for the most part, these are pretty. I mean, they're quite remarkable, really, if you think about like the PCs that I grew up with when I was a teenager. It's about the same level of compute, but in the grander scheme of things, this is like pretty simple devices. And then we're doing a lot of processing of time series, so lots of feature engineering on time series using Fourier transforms or wavelet decomposition, things like that, to try and extract features from these signals, and then pushing those features into pretty simple neural networks or classical ML models that are running on these devices. And it's all about low power and efficiency. That was the beginning, but then very quickly we started experimenting with vision. With TensorFlow Lite at Google, we did a cool project called Visual Wake Words. The team put together this data set of basically like cleaned up web scrape data with people, and we demonstrated how you could do like a person detector. So is there a person in the image or not? And this is using like a 96 by 96 little image sensor on one of these same Cortex M4 sort of ish MCUs, and running not quite in real time, right, but like fast enough that it's useful for an application, a couple of frames a second. I remember the first time I saw that, it just blew my mind. It's like we actually have a low power device that could run on a coin cell battery for like a month doing vision. Really crazy. And then it's just really gone from there. On both sides, right, the algorithms have got more efficient. People have got better at figuring out how to train smaller models. And then at the same time, the hardware has just got more and more capable. We've got devices that are built. At the beginning, it was kind of an accident that we had these devices that you could deploy deep learning models to, because the models can be quite big, like, starting at tens, going up to hundreds of kilobytes at the low end, then into megabytes or hundreds of megabytes. And we started off with hardware that just happened to have just enough memory or just enough compute to run something in a reasonable frame rate. And then once the companies developing the silicon started to realize the potential, we start to get these things that can run like real time, high resolution vision using convolutional models at the edge, and with the same energy consumption. It's just mind-blowing stuff. And so soon that was the main workload people are concerned about. We never really saw like a drop off of the time series stuff, but then just a whole load of new projects and opportunities and use cases and applications come in with vision. And so now we're starting to get to the point where we've got hardware that's capable enough to have models that are hundreds of megabytes or even like a gigabyte of weight, and they're still running quickly. And these are maybe not like going to be ultra low power, right, running on a coin cell battery, but devices that can be embedded inside of things, doing stuff on the edge. And people are doing things like vision language models. So you've got a model that can take images and text as an input, and that lets you use prompt engineering as a tool to define what the application is going to do at runtime. So it's different than the classic sort of world where you're doing supervised learning. You're training a model with a data set, because data sets are always hard to get. They're always expensive to get, especially in industry where maybe this is like a one-off thing that you're doing for one particular facility. So having this bigger hardware that can run bigger models, it just gives us this flexibility to try and use these approaches which reduce the need for large data sets. Now that doesn't get you, out of jail free with needing data. You still need data to test and develop. And as an engineer, you need to be really on top of evaluating the system you build. But we kind of are breaking into this whole new world now with all these capabilities from generative AI that are going to be possible at the edge, both for understanding sensor data and making decisions based on it, but also doing things like reporting or describing what's going on in a scene, or generating some audio, generating some video. So the world's changed a lot. I wouldn't say there's been a drop off of the simple stuff. That's growing too, but now there's all this other stuff that's also possible.
Very interesting, because it gets me to the basically next topic I wanted to ask you is about the model. Let's say you have a model and you train it and you deploy it on the machine, and you basically get the insight from that model. But there are many cases that not necessarily we are able to, as you mentioned, we don't have enough data, or we don't have a data set right now. We have to deploy the machine in the field to learn about the behavior of the machine, to collect the data, and then we will be able to basically classify and label the data set. And that's always a challenging. So with the narrowband communication, still should we send the data back to the cloud so we can train the model over there, and then we feed it to the machine through the OTA, and having the normal operation of the machine to detecting? Or no, there is a way that basically we can train, as you mentioned, with the Gen AI actually on the machine without sending all the data set back to the cloud. I would like to kind of expand more on that topic.
Yeah, so it's like the perennial problem where the edge is where the data lives, but it's not where the training happens. And so, like, if we're deploying these models there, but the models are dependent on data, how do we obtain that data, and how do we have it be good quality and let us do the things that we want to do? And it's really challenging, right? This is the number one problem, not just in edge AI, but in AI generally, is data and data quality. The more data you have and the better quality that data is, more importantly, the more you can do. And we see a lot of developers and a lot of businesses that have this type of problem where, maybe they just don't have much data. Maybe they are having all these individual facilities, each one's slightly different, or lots of products, each one's slightly different. Do they need a big data set for each one, for each particular application? And there's a few different technologies or a few different approaches that can help here, and it sort of depends how much bandwidth you have. So if you've got plenty of bandwidth, the best thing is if you can have this like semi-supervised kind of approach where you've got something running on the device which can help you collect data in addition to running the model. And when you have new data that seems valuable, you can send it upstream, and that goes into the data set. And you can be smart about it. You can say like, ooh, okay, is this for this input, the model was quite uncertain. So that seems like it would be a useful one to send back home and label and then maybe retrain on. Whereas if the model's very sure of something, then that may be not as useful. So you can kind of use tricks like that. But then say you've got a bit less data, less bandwidth, you can't be sending this data all the time. There are approaches like things like federated learning where you can train on device and maybe even send with federated learning. The idea is you do some training on device that improves the local model, and then you can send something of the weights up to a central location and share that across multiple models. And that's it's a really cool idea. The problem is it's actually really hard to use in theory, and same with on-device learning in general. And the reason is labels, because in most situations you need a data set that has labels. And what a label is just like some metadata that describes what the data represents. So imagine we've got like a manufacturing line and there's a product that's being produced, and we want to detect if there's a particular manufacturing issue with that product. So we'd want a data set. If we're doing visual inspection, maybe we have a bunch of images of the product that are, nominal, where it's looking good the way it should, and then we have a bunch of images of this particular problem that we're trying to detect. And those two sets of images, those need to be labeled by an expert who can, inspect the image and say, hey, this looks good, this looks bad. And once we've got that data set labeled, we can use it to train a supervised model. The problem is, on the edge, do we have access to those labels? Is there someone sitting there who's looking at it and saying, yes, this is right, no, that isn't right? A lot of the time, the reason we're trying to put this intelligence on a model and put it on the edge is because we don't want to have someone sitting there doing that, because it's, either just impossible, or it's cost prohibitive, or there's just too much to monitor, or we need it to be super low latency or something. So that can be really hard. But there are subsets of these problems where you can have labels on the edge. So for example, if there is an operator there who, when there's a problem, they shut down the production line, you can use that as a label. It's like, okay, how often is, what was going on when the line got shut down? If we've got some samples from then we can, infer that was something problematic. So there are also unsupervised models that you can train, and that's sort of a little bit different. Like, rather than having the labels, you've got a model that, maybe imagine like anomaly detection. So we want to detect when something's become different than normal. We can kind of cheat with the labels there. So if we make the assumption that most of the time things are normal, then we can sample what normal looks like when things seem to be going well, train the model on that on the device, and then the model learns what normal is, and then it can tell you when we've deviated from that distribution. And in theory, during a given randomly selected 10-minute period, hopefully nothing's going wrong. And these kind of approaches are useful when the thing that you want to detect is quite rare, so you don't have lots of samples of it. And that's actually a really common situation, to have rare events that you're trying to detect. So there's like different classes of models you can use for that. But then that comes to the last thing, which is like, what if you could just have a model that you can reconfigure on device without even having to do any training? So maybe someone operating the machine can do it, or just a technician plugs in and changes some configuration. That's something that's really interesting. It's called zero-shot learning, and it's the idea that we don't need any data to retask this system. We can just make some configuration change. And so the stuff I mentioned about vision language models, where you can change the prompt to do a different task, that would be zero-shot learning. But you can also do that with simpler models. It doesn't have to be a vision language model. There's just sort of ways of combining algorithms that let you do that kind of thing. So maybe you've got, you're looking at one product, you're switching the line to produce a new product, you want to capture some nominal images of that product, you just put the product in front and press a button a few times and capture a few samples, and then maybe the model can go from that. So there's various solutions you can use to sort of get around this, but it's always going to be hard. That's always the biggest challenge for companies that are doing this stuff. That's where things like synthetic data come in, and data augmentation, and also simulation. So these are all ways of taking a little bit of data or taking some domain knowledge and creating a data set from that.
That's really interesting. That's the part that it makes me super excited actually about the AI on the edge, and definitely I'm gonna have a session on that to talk about the training on the edge side, because as you mentioned, there are many applications that we are dealing with their rare classification and labels, and for those applications, definitely we need to do something like this. The other thing I want to check with you and ask your opinion, and the way the trend you have seen so far, is using not just one sensor or one input, multiple sensors. And basically between those data points, we can decide what is the output and what kind of insight we can share. how is the trend right now?
Yeah, so this sort of idea of like multiple modalities or sensor fusion, where we're combining input from multiple sensors, it's really important, really interesting. It's not something new necessarily because people have been doing this stuff with like just regular algorithms for a long time, right? Looking at like what two sensors are saying and triggering some behavior based on that. But that's also something that machine learning models can do. And ML models can be particularly good at spotting kind of weird relationships between things that are hard to pick out as a human being. And the more sensors you add, the more likely there are these like difficult to spot relationships that can be indicative of something. So we have tons of customers that are doing things like that, like taking the sort of stream of data from multiple sensors and then running those through a model that's designed to detect when some kind of state is occurring. That's also, and that includes like images, audio, time series. You run into some challenges around like, okay, what if your data is coming in at different rates? So you've got different sensors at different sample rates. Maybe you've also got inputs that aren't necessarily sensors, but it's like, what's the current state of the machine? Is it switched on? Is it being used? That type of thing. And they all kind of can be plumbed together and used to train a model that does some kind of classification of what's going on. And that trend isn't ending with the bigger models like the generative AI stuff. We've got models now that can take images and audio and text and all of these sorts of things and do something with it. And they're only going to get better. There are people working on foundation models that can incorporate data from time series sensors or physical models of the world and all of these types of things. So I think over time, this stuff's just going to get more and more useful, more and more important. And the holy grail really is to have this sort of shared space that has things that are related to each other, are close to each other in this space of representation that can be applied to any sensor modality, whether it's audio, different time series sensors, video, text. And that allows us to kind of make these associations in a very straightforward way. And I'm sure that we'll end up with that type of representation at some point in the near future.
Definitely, definitely, yeah. You're absolutely right. So far we talk about the concept and whatever behind these models and how we can train them. Maybe it's not a bad idea to give one cool application that you have seen so far. I can start. For example, when I was doing my PhD, actually, my project was about making a smart sensor for a smart grid. Basically, you deploy it every 2 miles, and the sensor is going to inject a high frequency signal. The other two sensors, they're going to block the signal. And now, through the impedance of the line, we can detect the failure or if the line is touching the trees. At the time, the edge AI was not a big thing or almost nothing at the time. So our calculation, our computation was really either we had to send it to the cloud side to do it, or if it was on the device itself, it was really simple. But now I'm going back and think with the edge on the AI and with the AI on the edge, we can do even more. We can do more complex failure detection for the smart grid actually. But what is the experience or the application that you want to share that once you think about it, it makes you excited actually?
Well, the thing for me with this, what keeps it endlessly fascinating, is it's like whatever's topical right now, whatever's in the news, whatever people are concerned about, there's some company working on using Edge AI, applying it to that. So you mentioned smart grid, like we have a customer who's using Edge AI. In fact, we have a number of customers using Edge AI for monitoring, power lines and identifying whether there's an issue. And you see things like the fires in Southern California and things like that that are happening every year as a result of these types of failures. It's always topical. If you care about conservation and the environment and monitoring wildlife. There's all sorts of researchers out there who are doing innovative things with edge AI to understand like wildlife populations. So they've got camera traps or other sensors out in the field, which are out there for months at a time, ultra low power, collecting information about how many animals have walked past of a certain species and sending that information back. In industry, manufacturing is a big topic at the moment, and there's so many companies using edge AI for so many tasks, whether it's predictive maintenance, making sure that you're able to detect issues with a production line before they get to a point that is going to cost a lot to fix. Visual inspection of manufactured goods for quality, safety in the workplace. There's just so many applications, and these are some of them are computer vision. Some of these are using sensors that are like time series, like physical, mechanical, like vibration, accelerometer, things like that. There's more exotic stuff too, like radar or lidar. All of these things can be fed into models. And then health as well. I'm a big runner. I love fitness stuff, and there's so many cool things you can do with edge AI, looking at like classifying what kind of activities people are doing, understanding what's going on with their body based on these biosignals like heart rate and EEG, ECG. There's customers we've got that are using edge AI to interpret brain waves, to understand like your brain activity and help you relax or help you focus. So that's what really excites me about it, is it's just almost everything. There's some kind of application for these technologies, and we're at this stage where at the beginning it was all about educating people, like, hey, did you know these things exist and they're possible? And like in your domain where you're an expert, can you identify any places where you can deploy these? And what we're seeing now is that people really are finding these opportunities, and the challenge now is not like, are there any opportunities? It's like, how can we as engineers effectively build solutions to do all of these different things?
Great. Thanks for sharing. So now I want to change the gear a little bit. Actually, we talked about the application concept. Let's go back to the Edge Impulse. And as you mentioned, recently we heard that the acquisition with Qualcomm. First of all, to me, I have seen this trend before, and to me it's a wake up call for the hardware manufacturer. I mean the hardware all the way from the chipset, go up to, let's say you're making a big, let's say, oven or refrigerator, whatever. So the wake up call is you cannot just sell the hardware anymore. If you want to stay in the game, it's going to be the platform or the ecosystem that you're selling. And this ecosystem is going to be the hardware plus the service plus the AI plus the cloud and everything together. And that's how you can keep your customers. So first of all, to me, is a wake-up call for other semiconductor companies. The piece that makes me a little bit worried, first of all, I'm really glad for you guys and this acquisition. But the part that makes me worry is, I want to ask you, how do you see the Edge Impulse in the future? Is it going to be just for Qualcomm basically chipset, or you are going to continue basically offering the service for other semiconductor companies? If yes, how you want to resolve and address this challenge of competition?
Yeah, so I mean, it's a good question, but I think, it's kind of an easy answer as well. We've always been this neutral ground where we support a whole ecosystem of different types of devices, different types of products, in the same way that we support a whole ecosystem of different machine learning models and signal processing algorithms, because you can't have a tool like this be useful unless it supports everything. We need to be there in the design process where people are selecting hardware, right? We need to be a trusted neutral ground where you can evaluate the model's performance on different types of targets and make that kind of decision. And then we also need to be there for customers who are doing multiple projects. Not every project you do is going to involve the same hardware, the same chips. Even within one project, you may be using multiple devices from different suppliers. So Qualcomm, the reason we're so excited to be joining them and why this is a good fit and this is something we said yes to is because they completely believe in that vision too. And Qualcomm makes some incredible hardware, and we're going to be supporting that. But at the same time, we can't make a product like ours work unless we support that whole constellation, the whole ecosystem that engineers are building on top of. So Qualcomm really gets that. That's not going to change at all. We're still working with all of our partners. They're excited to be working with us. So it's really just about growing this entire pie for everyone, right? We've now got a ton more resources to grow the community, to push out into more and more embedded engineers, help people get trained up and knowledgeable about edge AI and the things that are possible, help build tools that de-risk the process of doing edge AI engineering. And that's going to benefit the entire community because you're never just going to work with one piece of hardware for the rest of your life. You're never going to be using one piece of hardware for every project. So I think our vision just carries on, right? We're carrying on as a business in the same way we always have. Our business model's the same too. We have our community platform which anyone can use. If you're doing something big, if you're pushing lots of stuff to production, then you can come on and be an enterprise customer, and we give you all sorts of support. We're going to continue to do that, and we're just doing so under the kind of Qualcomm family now, and we're just part of a bigger constellation of pieces of Qualcomm that are providing services across the whole ecosystem.
Great. I'm hopeful for a good future for all of us, actually. And I really appreciate the work you guys have done on the Edge Impulse side. I have used your tool. I like it. And my team, they use it. They like it. So I'm hopeful that we can continue, actually. And all of us, we can continue with the great platform that you made. For closing our conversation, actually, I would like to ask your vision, because now we're talking about the Gen AI, agentic AI, and the AI and the machine for the sensors. How do you see the really innovative collaboration or interface between these two worlds, the agentic AI, that model and the machine? What's your vision in the next 4 or 5 years? What should we see?
Well, yeah, I kind of love at the start of our conversation, you said, people are going to be creating things that no one has thought of yet. And I think, that's so much the case here. That's why it's so exciting, is that we're in this moment where so many things are going to be born that it's hard to anticipate what. But I think just like if we start out with the problems that currently exist in this space and how some of these technologies will help address those, we've got things like data availability. As we mentioned earlier, some of these technologies can help with that. Not just like running the foundation model on device for zero-shot learning, but also synthetic data. Like, can we use generative models to create data that we then use for other things? Or even stuff like, you can now take a few images of something and turn that into a 3D model. And then we can use that inside of a photorealistic simulation to build a big training data set that we can use for computer vision. And you train that model on that data set. The model you train can be tiny, right? That could be like a 70 kilobyte model running on a microcontroller that's been trained on a data set that was generated by a like 10 gigabyte foundation model. So really crazy potential there just for using this stuff in tooling. And I think that's the first thing we'll see. And then we're going to see, this generative AI on device in a kind of zero-shot context, being able to reconfigure on the fly what the system is doing. These bigger models are using more energy, but they're getting a lot smaller over time, and the hardware's getting more energy efficient too. So we already have recently hit this inflection point where it kind of crossed over and it became feasible to do this stuff in real products. But that's only going to continue. So we'll have more flexibility about how you can change the system when it's deployed. That doesn't take away the need to do constant evaluation and monitoring of this system. It makes it even more important, in fact. So that's always going to be a real key thing. And that's something that we're looking at in our platform. It's like, how do we build tools that support the developer in long-term monitoring and maintenance and improvement of their system? But then the next thing is like, what about actually generating data on device, and what are the applications for that? And there's sort of the one side where we're talking about generating content. We see a lot of models for video and audio generation. I don't know, in a few years, am I going to have like headphones which generate music for me while I'm walking around based on the scenery around me? Like, that's a stupid little idea, but like, there's so many things, video games. Are we going to be playing video games that are rendered using a game engine on a GPU, or will we be running a model on the GPU that rendered? And in fact, NVIDIA GPUs now are using generative AI to render a lot of the pixels that are in the resulting images. That was something that was discussed in the keynote in GTC last week. So all these applications there for generating audio, visuals, text, like conversational UX, interfaces that allow people to have a back and forth discussion with the piece of technology that they're using. So that's all up for grabs too. A lot of that's been possible in the cloud in the past, but it really changes the game when you can run things on device and you don't have any privacy issues, you don't have internet connection or latency problems. But then the big kind of final thing that is crazy to think about is, we talked about multimodal data as an input. And so what if you've got these models that are taking all this multimodal information about a context, and then those models are generating control signals directly to control some system. So, rather than having models just do a little bit of sensor processing and then a handwritten application that does whatever task, whether it's letting your Roomba go around your house or whatever, kind of thing. If you look at the forward march of technology with deep learning, the more you can do in the model, the better it seems to be. So we see that with, machine translation. We see that with self-driving and autonomous vehicles. And so we'll see that with robotics, I think. It's like the models are going to be taking in information and they've been trained using some kind of simulated environment or something like that. And then they're outputting control signals directly to whatever it is that's making things happen in the physical world. So I think that's going to be empowered and enabled by this bigger compute at the edge, but also as we get better at the synthetic data and the simulation and all of that good stuff too. So really exciting time to be an engineer in this field. If anyone's listening to this and wondering if they should dive in, I think now's the time. There's so much up for grabs in terms of cool stuff that people haven't quite done before. So, really, really awesome time to be working in this field.
Yeah, I love your vision actually, Dan, and specifically the one that you mentioned about the headphone that generated music. I love it actually. So that's a cool idea.
Hey, there's
And
a
hopefully someone is
startup idea for
yeah,
someone
exactly.
to have
Maybe
for
it's
free.
already a startup. I don't know, but if someone is listening, that could be your on your application for maybe YC that as you're applying. So
Yeah,
we can go.
next time I'm on this podcast, hopefully that
Yeah,
product
that
is
was
on the
great
market.
actually. So one last personal question for you. I read your book and I love it. My question is why you're writing a book and taking time to write a book actually. And it's not your first book actually. You have a tiny ML as well, but why you're writing a book?
Oh, I mentioned at the a beginning of all of this with what we were doing with Edge Impulse, and then before that at Google. The big problem was that we had this new technology that most people didn't know it existed. Most people didn't know these things are possible at all. And so part of the issue was like, how do we get the word out that this stuff is possible? So that's part of the motivation behind the book. But also, this as a field of engineering, AI at the edge is very young. it has stuff in common with other fields like regular AI or data science or embedded engineering, but it also has some pretty substantial differences in the way the workflow works for AI and machine learning compared to conventional software engineering. And that's something people weren't very familiar with. Even things like, how do you build a team? How do you put together the squad that is going to build a product around this? What are some of the hairy issues you can get into and pitfalls that come from, data oriented engineering as opposed to, the traditional ways of doing things? So we thought it was really important to write a book to give people this sort of baseline, give people some guidance in how to navigate this new space. And we're going to do a second edition at some point that incorporates all the stuff we've learned since and some of the new technologies and that type of stuff. And the field's moving forward, and there's tons of people learning these kinds of lessons about how to support real products. But we wanted to share some of the stuff that we'd encountered through our work at Edge Impulse and at other companies that our team had worked at. It is a fairly horrible process writing a book. It's very time consuming and stressful, but a lot of that book was written during COVID, so there wasn't much else to do apart from stay behind my desk for another few hours in the evening. But actually at the time I was traveling around the US, living in different places, and so a big chunk of that was written while I was living in Southern California in Joshua Tree, and I go out for a hike and think about what needs to go in the next chapter. Big parts of it I was living up in Washington, going camping out in the forest. So it was like kind of a nice thing to have that space and time to do a bit of writing.
And for those of you that you're just joining our video, most probably, we're not talking about the book in the art. Actually, he's talking about the book in the Edge AI that you wrote it in the forest and jungle, and that's really interesting. Actually, that's very interesting. I should read it one more time actually, and with the mindset that where you wrote that book actually.
Well, give it a few months and hopefully we'll have a second edition. Well, maybe not a few months. Give it a little bit of time. Hopefully we'll have a second edition that covers some of the unbelievable amounts of things that have been invented in the couple of years since that book came out.
Great, great. And for my audience, actually, I'm going to put a link that you can download the PDF version of the book, or if you're like me and you prefer to actually have a hard copy, also I'm putting a link that you can go and buy the hard copy version. But I really appreciate the time today that you spent with us. It was very impactful. It was very good for me actually to understand the aging pulse, the future, and also your vision regarding the AI on the edge. Thank you so much for your time.
Well, thank you, Amir. Really grateful to you for having me on the podcast, and grateful to the audience for listening. And yeah, go download the book and start your AI at the Edge adventures.
Thank you so much. I appreciate it.
Cheers. Bye
Have a
bye.
great day.